All right, we will continue with our inverse discussion today. And if it's like the other two classes so far, we are going to get very close to finishing, which is good. We'll just wrap up whatever problems we have left tomorrow. Remember, tomorrow is not only the end of the 6 weeks, but I'm going to budget about 20 minutes in class for you to go ahead and take your exit ticket. This is the first grade of the next 6 weeks, and it will be covering what? The difference quotient. You remember f of x plus h minus f of x all over h? Okay, you'll apply that to a function, simplify, take the limit as h approaches 0, and find me what we refer to as the derivative. So I'm not going to tell you what it is, but I'm going to go ahead and tell you that it's a function we have not seen before in this class. Okay, or I should say work together. Okay, we did a linear function, we did a quadratic, we even did a rational with the difference quotient. So it won't be any of those, it's going to be another parent. Okay, just be thinking about that. Next week, what's due on Monday? Okay, that's your homework, your composition homework. So if you get the homework assignment turned in on Monday, then I'll go ahead and start putting points in your point bank. And sometime in the second 6 weeks, we can start applying those to maybe a test grade or a quiz grade if that's what you would like to use those for. And Tuesday, I'm looking to have a quiz over compositions. All right, so we'll turn in the homework Monday, talk about it. We'll take a quiz over compositions on Tuesday. I believe that's the first day of October. And then right now, next Friday, the 4th, I have an inverse function quiz scheduled for that day. So we're going to be getting 3 grades next week, the first week of the 6 weeks. All right, and we'll have the homework. I'll have that ready for you tomorrow for inverses, and I'll let you know when that's going to be due. It'll probably be due about the middle of the week, okay, something like that. But any questions about what's coming up? All right. Well, let's see. Somebody tell me something about inverses that we learned yesterday. Like, what are we doing with inverses? What are they? Stuff. Okay. All right. So we're going to start broad. Now let's start to chisel away with that. A little more specific. Okay. Well, let's talk graphically. Okay. What's important to an inverse graphically, or how would I find the graph of an inverse? What's my line of symmetry? Y equals x. Okay, the linear parent. Okay, if you want to see what the graph of an inverse is going to look like, whether it's a relation or a function, you reflect it across this line y equals x. Okay, so that's one thing. We know our notation is to use the -1. So F inverse, G inverse, etc. But what's the core idea? What are we doing with the domain and the range? We are switching them. We take the x values and the y values and we switch them. The x's become the y's and the y's become the x's. And one thing we're going to be able to hopefully do today before you take off, we're going to use the composition, what we talked about earlier in the week, to actually show if two functions are inverses or not. Now, one thing we like to do yesterday, we practiced this, we wanted to go ahead and use what's called the horizontal line test to tell if a graph is 1-to-1 or not. What am I referring to there? Okay, Natalia?
If there are two y values that are the same.
That's exactly right. The horizontal line test is going to tell me if any values of y repeat. Okay, so if it passes the horizontal line test, no values of y repeat, we're good to go. If it fails the horizontal line test, that means we do have repeating y values. Why would that be a problem with an inverse? Remember we said, what do we do with the x's and the y's? We switch them, right? So if I have repeating y values, they're going to become what? Repeating x's. It's really important to us that our inverses be functions. If it's not a function, well, then we refer to it as an inverse relation. I believe we did one yesterday, B, that turned out that way. The example I'm going to show you today, how do we guarantee that my inverse will be a function? That's what I want to do. Okay, so we got through some examples, and every class was different. Did we get through C? So we did finish C. All right, good, good, good. Now, we don't have to worry about that. Let's go ahead and move on. to some application problems. I guess application is kind of a loose word to use, but what's important here is being able to look at an expression and understand what it's telling you. Okay, so next example. Let C of M be the cost in dollars of M ounces of mangoes. What do the following statements tell you? Be sure to use units. Okay, so I've got this function C, and they probably went ahead and named it C because, function C is going to give me the cost, but cost is just one of my quantities here. What's the other quantity I'm dealing with? Okay, the mango, specifically the number of ounces of mango that I can get. So for the original function C, what's my input? Which quantity is it? There you go. The input is the number of ounces of mango. I plug that into function C. What's the output? What do I get? The cost. That's exactly right. So knowing this, if you see this expression, C of 12 equals 0.75, what is that actually telling me? That's exactly right. Okay, 12 ounces of mango costs 75 cents. Okay. Or you can just put 75 in the C with a little bit if you just want to do number of pennies, completely up to you. Because it said it was in dollars, that's why I did that. Okay. All right, so B, if I have the statement C of 8 equals 0.5. Okay. Caleb, what would you say this is? Like, how would you verbalize that statement? B. There you go. 8 ounces of mango costs 50 cents. Okay. Perfect. Okay. Now, I'm not always the best example. I always encourage you to go ahead and write in a complete sentence. All of your teachers would. I don't always do that. I'll try to do that. But you'll notice what happens with C and D. Now we're taking the inverse. Okay, so think about my quantities here. Originally, we input the number of ounces in order to get the cost, right? So what's the input for the inverse? There you go. Remember, we're taking those two quantities and we're switching them. The inverse has me inputting the cost to get what output? The number of ounces of mango. All right, because I really like the way this does it, especially the upcoming examples with the quantities we're going to look at, because a lot of times when dealing with inverses, we just say, okay, we're taking the x's and the y's and we're switching. Okay, well, now we're actually having to do that with the quantities. Presumpsa, what would you say for the statement C inverse of 3 equals 48?
That's $3. Or you can say, it's 48.
Yeah, remember, there's different ways to say things. The first way you started, $3 will purchase or will buy 48 ounces of mangoes, or 48 ounces of mangoes cost $3. Okay, same thing. I'm going to go ahead and say it the first way. I'm going to go from the input to the output. So I'm going to say $3 will buy, 48 ounces of mango. Okay. $3 will buy 48 ounces of mango. Okay. So what should I be putting for D? C inverse of 0.75 equals 12.
12 ounces of mangoes cost 75 cents.
Okay. Now again, I'm just going to go in the same direction, but you're absolutely right. Okay, so 75 cents. Okay. We'll purchase 12 ounces of mango. Okay. Easy, right? Okay. Now let's go ahead and start to expand on this idea. Okay, comparing the two quantities, kind of articulating what it is that it's trying to tell us. So now we have another example, different scenario. Suppose W equals P of X is the average daily quantity of water in gallons required by a palm tree of height X feet. Okay, so what are my two quantities that we're comparing here?
Water.
Okay, the number of gallons of water and the height in feet. Okay, so it looks like this function P relates the two. So A, what does the expression P of 25 represent? So think about the original function and the definition we were given. Does that initial 25 right there, does that represent the height of a palm tree, or is that the number of gallons of water? Okay, so I'm hearing a lot of people say height, but I did hear a few gallons of water. Which one should I go with? It is the height. The original function, whatever P does to that value, okay, you plug in the height of the palm tree, the output is going to be the number of gallons of water that you're going to receive. Okay, so we know the idea, so now we just have to write a sentence saying that. For example, I said P of 25, that's the average daily water needed for a 25-foot tall palm tree. Okay? Just straight to the point. Okay? Doesn't have to be anything incredibly long. But the point here is I'm trying to help you say what it is that you're thinking. Okay? We need to be able to communicate. Okay? So let's try B. What does the expression P inverse of 25 represent? Okay, so now you said the quantities were the height of the tree and the number of gallons of water, right? So what does the inverse do?
25 gallons.
There you go. It switches those quantities. So Natalia, what are you saying? Okay, so the input for the inverse is the number of gallons of water. So what would that give me?
The height of a palm tree needs 25 gallons.
Okay, so Andrew says the height of a palm tree that needs 25 gallons of water. I think that's perfect. Okay. All right. That's almost exactly what I had written right here. The height of a palm tree that requires 25 gallons of water. Okay. So remember, for this scenario, the original function P, the input is the height of the tree. The output is going to be the amount of water. The inverse switches that. The inverse's input is the amount of water, and the output's the height of the tree based on the amount of water. Okay. So let's try a couple on our own. C says, what does the equation P of V equals 50 tell you about V? Okay. So think about what I just said. Okay, we're dealing with the original function. You have to know what the input is, what it represents. And then he goes ahead and says, rewrite this equation in terms of P inverse. Now that one should be pretty straightforward. If I'm given the statement P of V equals 50, what would the inverse statement be? P inverse of 50 equals V. That's exactly right. Okay. So write down what you think V, okay, is giving you in that expression. Okay, so see if you can come up with a complete sentence. And let's see if it gets close to what I'm going to have. And here's the point. Is it always going to be 100% exactly what I write? No. Okay, everybody's going to be writing different sentences. Okay, there's a lot of different ways to say the same thing. Okay, the idea is to get your point across. Okay. So does anybody want to go ahead and tell me what V would represent? What did they put on their paper? Anybody? Anybody at all? Or do I have to randomly call somebody? Jake. Okay. Now, palm tree requires 50 gallons of water daily is what he said. I think that's good, but you forgot one crucial element. You mentioned the water, which is one quantity, but you didn't mention the height, and that's specifically what this one was asking me about. What does this tell me about V? So we know that it's going to require 50 gallons of water, but what will? A tree that's what? What's the height that I'm given? Oh, no, that's the water. Remember, 50 gallons of water is needed for a tree that is V feet high. See, we were given a variable, it's my unknown, so I'm still going to incorporate him. Now, what I said, V is the height of the palm, needing 50 gallons. Okay, so that was still really good. He got one of the quantities, but just not the other one. Okay, questions? All right, well, let's try the last one here in this section. It says palm trees are on average Z feet high And a tree of average height requires K gallons of water. So now they're giving you specific variables for our two quantities. Z represents the height, K represents the water, okay, the number of gallons. Represent this fact in terms of P and P inverse. Okay, so this one you're just writing out a statement very similar to the one we did a moment ago. Would anybody care to give me the normal statement P? P of what?
P of Z equals K.
Okay, Natalia says P of Z equals K. Is she right? Perfect. Because remember, P, the input is the height, the output's the water. So what would the statement for the inverse be?
Or is P or
Okay, so Andrew.
inverse of PK or inverse sorry P of K is
Okay,
Okay.
you're getting it. You're getting it.
yeah, P of K is equal to Z.
P of K equals Z.
Yes.
Oh.
Oh.
Now remember, P is your original function, so P inverse of K should equal Z. There we go. Okay, we got it. We got it. Okay. All right. Now, they went ahead and identified the height as Z, K is the number of gallons of water, because the next section will be using the same quantities. Okay. So we've got 8 different statements here. You'll notice the first 4 are the regular function P, where height is the input, water is the output. But starting with number 5, it's the inverses. So remember, we're going to switch those quantities. But also another aspect of this, you have to decide, are you affecting the input or are you affecting the output? And you have to know what is the input in this scenario. Okay, for the original function and then for the inverse. Let's try the first one together. P of 2Z. Okay, so don't worry about the 2Z. For the original function P, what's the input? Is that the height or the water? So the input for the original is the height. That should give me the amount of water needed for that height. Everybody's with me? Okay, so what's being affected here? The input or the output? The input. See, I know because Z is being affected directly. Well, how am I affecting it? I'm doubling it. So what does that mean in terms of my quantities? What am I doubling? Okay, so P of 2Z, I would say probably something along the lines, this is the amount of water needed for a tree double the average height. Maybe something along those lines. Okay, and remember, that's not going to be the only way to get that idea across. So what I want you to do is try these other ones. Then we have 2 of PZ all the way down to P inverse of K minus 2. So I'm going to go ahead and give you 4 minutes, and I suggest that you go ahead and probably get, maybe 2 or 3 of these done, and then kind of lean over to your villain buddy and see if they're getting roughly the same translation, the same expression. Yes, ma'am. Well, I'm actually going to put it up there in just a second. I've got a whole other one. But I think, what did I say? Something along the lines of the amount of water for a tree double the average height? Okay. All right. So I'm going to give you 4 minutes. And you may not get all those done, but at least you'll have the opportunity to work through some of these. Do 1 or 2 of the normal functions, and then try a couple of the inverses. Okay. And then lean over to your partner. What are you getting for this one? Because it's water and height, right? What are you getting for this one? That's gone over as well in this class as it has in the others. But I will keep using it. Okay, if you're having trouble with this, don't worry. Okay, by the end, we will get to the root of this problem. Because it's true. Okay. You don't get that one? Okay. Well, trees have roots. The roots soak up the water so the plant can live. I'm just trying to branch out into some new jokes. Okay. I think Neo believes I should just leave it alone. Hello, is this thing on? Hello? Okay, good Lord. Yeah. Don't worry, if it's one thing you can say about this class, my jokes, their bark is worse than their bite. Tree jokes. Mercy. Okay, we are now passing the 2-minute mark, so I would encourage you, kind of lean over to your villain buddy, see if they're saying roughly the same thing. Odds are it's not going to be verbatim. Okay, that's 4 minutes. You may not be completely done. That's all right. Okay, what I'm going to do, I'm going to get myself a calculator. Okay. And I'm going to go ahead and use it to randomly choose people to help me out with these. It's better that it's not completely random, but it is more random, you have to admit, than my just choosing people arbitrarily. Okay, so let me go ahead and pull this up very quickly. Menu, random. And here, Clarissa, are you in seat number 30? Okay, so the highest we're going to go is 30, so 1, 30. Okay, so let's go ahead and take a look. Let's talk about this first one again. We knew we were dealing with the input because what was being affected? Okay, the height. Oh, now, the output is just the number of gallons of water, but I'm not changing that. This is the amount of water needed for, we said, a tree double the average height. Okay. So how do we know, compared to that in 2, that I'm affecting the output instead of the input? Yeah, what am I doing to Z? Absolutely nothing. In fact, it's the function itself that I'm doubling. Okay, and the function is what produces, in this case, the amount of water. So let's see, with that idea, 20. Okay, so I believe that's Kasha. All right, so what would you say for 2P of Z?
Double the average water needed for a tree that is average height.
Sounds perfect. Double the average amount of water for a tree of average height. Okay, here's what I had written for both of those. Water for double the average height of a palm, double the water for an average height palm tree. And you can either, talk about the quantities themselves, or you can even go ahead and incorporate the variables, in this case, Z and K, if you want to. All right. All right, so let's try 3. P of Z plus 10. Okay, so let's see. 15. Nobody is sitting feet 15. 23. No one is 23. 11. That's Xavier. So Xavier, what would you say for P of Z plus 10?
Average water needed for a tree of average height plus 10 feet.
That's exactly right. We're changing the height of the tree. We're increasing it by 10 feet, so the amount of water needed for a tree 10 feet taller. Perfect. It's perfect. Okay. Next one is P of Z plus 10. I got 9. So Caleb. So what would you say for P of Z and then plus 10? What's being changed here, the height or the water? The water, okay. So how's the water being changed? Okay. So 10 more gallons of water for what? For the average tree, okay. So this is what I had originally put, water for a palm after it grows 10 feet taller than average, okay. And 10 gallons more water for the average height palm tree. Perfect. Okay, is there anybody who's getting sentences or phrases that are just completely off this? Is anybody having trouble? So everybody's doing good? Okay, so Jordan, you're not? Okay. How can I help you? Okay, so Jordan, what did you put for 4? Nothing? Did you put something for the another one? So you didn't write anything down? Okay, so I'll tell you what. Jordan, you're going to help me with the next one. Okay. All right. Because, I mean, the way to start understanding, is just getting in there and doing it, right? Okay, just trying something. Okay, so now, what do you notice about 5, Jordan? What's changed? It's an inverse. Okay, so we still have our 2 quantities. We're dealing with the height of a palm tree and the number of gallons of water it needs, right? What's the input for the inverse? Is it the height or the water? What do you think? It's the water. For the inverse, I'm going to substitute the water in, and what would that give me? Okay, so if I plug in the amount of water I have, what would the function give me? P inverse. What's the other quantity? The height. Okay, so we know for these 4, okay, I'm going to input the water to get the height out. So here's my next question. P inverse of 2K. What's being affected here? The height or the water? What am I plugging in? The water. How am I changing the water? Okay, that's exactly right. So I have double the amount of water for what? What was the other quantity? For the average height of a palm tree. Okay, that's all there is. So I kind of walked you through that one. Now you're going to help me with 6. P inverse of K plus 10. Okay, so you got to think about what's your input, what's your output, which one's being affected. Okay, so what would you say is happening if I gave you this statement? P inverse of K plus 10. That's exactly right. 10 more gallons of water, and what am I getting out of it? The height. What kind of height? Looking for a specific word. It starts with A. There you go. Okay, now put it all together. 10 gallons more of water for the average height of a tree. Very good. Okay. It's almost exactly what I have up here. That's perfect. Twice the amount of water for a tree Z feet tall. There I went ahead and used the variable. 10 gallons more water needed for a tree of average height. Tremendous. Okay. We got 2 left. I will keep trying no matter what. All right. What do we got here? For 7, P inverse of K and then plus 10. All right. 13. Fernando. So what would you tell me P inverse of K and then plus 10 means? Okay. And first ask yourself, what's being changed? Am I changing the amount of water or am I changing the height? The height. Remember, for the inverse, what are we plugging into the parentheses? The amount of water, what I get out of that is going to be the height. So how do I know I'm changing the height here and not the water? Where's that plus 10? It's outside what? What's that? Oh, not the inverse. Starts with a P. I tried to form it with my hands. Not very well because I have a calculator. Parentheses. Okay, the input goes in the parentheses. We said that's the water. We get out the height. So this plus 10 is outside the parentheses. So what is it affecting? Height or water? Okay, so what are we doing to the height? Okay, so a palm tree 10 feet higher than average. Okay. Okay, average water, okay. Now, we'll see what I put up there in just a second. Okay, and the last one here. What do we got? P inverse of K minus 2. This thing will pop up. 19. Philip. Okay. The height of an average tree minus 2 feet. Now, you mentioned the height, but what's something you didn't mention? The amount of water. So let's incorporate that in there. So let's say the amount of water needed for okay, an average tree minus 2 feet. Probably would have said like an average, like a tree 2 feet shorter, something like that. But that's fine. That's fine. You're getting your idea across. That's what's important. Okay. Here's what I put. Water needed for a palm 10 feet taller than average. Water needed for a palm 2 feet shorter than average. Okay. All right. Are we feeling better verbalizing what we're thinking of? Or at least, are we thinking of these type of things when we're looking at these functions? That's really what we need to be doing. We need to be understanding what the math is telling me. Jordan, is that good? Is it a little better? Okay. All right. Okay. Well, let's actually do some math now. We should probably do some math in math class. Okay. Move away from the English portion of it. All right, so this is basically a reprint of what you got earlier in your packet. If we want to go ahead and find the inverse algebraically, first we're going to determine that an inverse exists, checking if it's 1-to-1, switch the positions of x and y, solve for y, state the restrictions, and then if what we finish up with is an inverse function, only if it's a function do we go ahead and replace y with the notation. Okay, so let's kind of bring all this together here. All right, for each of the following, sketch the function, find the inverse, sketch the inverse, and verify their inverses. Okay, so first off, I want to go ahead and start with just a sketch of my original function. Okay, it's definitely the quadratic parent, but what's happened to it? What transformations do we see? Okay, so reflected, so it's opening what direction? Down. And what else? 2 units up. So the whole graph has been shifted up 2, and then it's reflected down. So you're probably going to be looking at something like this, where your roots are going to be about 1.41 on the other side, positive and negative. Does anybody want me to elaborate on how I know that? No? Okay. So here's the thing. First, we want to go ahead and determine if this guy is 1-to-1. So let's see if I can do this without my mouse. Of course I can. Maybe again. Okay. So I'm going to go use my mouse. All right. So I'm going to take this horizontal line right here. So I'm sweeping it up and down through my function. What do we think? It is not 1-to-1. I have repeating y values. So here's the thing. I want my inverse to be a function. Okay, so right now he is not 1-to-1. Okay, so let's go ahead and do this. Would everybody agree that his domain right now is all reals? He's infinitely wide? Okay. What would you say his range is? How tall is he? Negative infinity to 2. Is the 2 included? Yes. Okay. Now here's the thing. if I want my inverse to be a function, okay, then I have to restrict the domain so that he will be one-to-one, so that there are no repeating y values. Now, what this means for the parabola, basically, I got to cut half of him loose. And it does not matter which half. I can go ahead and cut the left half loose. Okay. Now, if I put that horizontal line through, will there be any repeating y values? No, they're all different. Okay. Now, see, here's the thing. Even if I don't do this, I'm going to get algebraically the inverse that I need, but we won't be able to call it a function. We have to restrict the domain. Now, here I cut the left side off, but there's nothing saying you couldn't cut the right side off. As long as you restrict the graph so he does pass the horizontal line test. It's really your choice. Choosing one is not more correct than the other. Like I said, you're still going to get the right inverse expression, the equation. Now, your graph is going to look differently depending on which side you choose. Okay, but I'll let you guys decide. Okay, what would you like me to cut away? The left or the right side? Left. Let's cut away the left. Okay. Okay. Now, I'm going to have to go ahead and change a few things. If I restrict him to only the right side, well, what's his domain now? Okay, 0 to infinity. See, I'm restricting his domain because I want to end up with an inverse function, not an inverse relation. And because I did that, it is now one-to-one. Okay. So now the problem is just like we did yesterday. Okay. I'm going to go ahead and take x and y. Remember, f of x, those are your y values. What am I going to do with those again? Switch them. So x equals 2 minus y squared. Okay. Now what? Yeah, and now just solve for y. Heard a couple people saying subtract 2. So x minus 2 is equal to negative y squared. Now, there's something I want to do before taking the square root. Yeah, there you go. We were subtracting y squared, so make sure that's a positive. So you can multiply through by a -1 or divide however you'd like. So negative x plus 2 equals y squared. Okay. Now we'll take the square root. Okay. So y is equal to the square root of negative x plus 2. And then, here's the thing. Would I go ahead and put the plus minus on front of this? Okay.
Because you took away one side.
What's that, sir?
Took away one side.
There you go. So remember, we're only going to be ending up with half of a parabola. But what should I be using here? Should it be the positive or should it be the negative? And maybe what can help us here is seeing what the reflection looks like. Well, we know that we have the point 0, 2. We know the point 2, 0 would have to be right there. Okay. So think about this. I'm going to rewrite it. Okay. Negative x plus 2. What direction was I shifting? According to the point I put on my graph, it looks like it was shifted where? To the right 2, correct? But wait a minute. When we look at shifting horizontally, don't we do so based on the opposite?
But you have to factor out the negative.
Say it again, Natalia.
Factor out the negative.
You got to factor out the negative. You can't tell the direction you're shifting unless the coefficient of x is 1. So she's absolutely right. So I'm going to factor out that -1. This is going to leave me x minus 2. So I was correct to go ahead and shift it 2 units to the right. Okay. Well, what's the negative going to do if he's inside? We know it's a reflection, but what's it going to reflect with? Is it the x-axis or the y-axis? Okay. It's the y-axis. It's going to reflect him backwards. So it's probably going to look something like this. I have no idea why that went red. Okay. All right. Now, I remember, like yesterday I stated my sketches are not 100% perfect, but if you were to go ahead and fold along that line, do the two come together nicely? Okay. Or at least they should. I mean, it's pretty close. Remember, it's just a sketch. Okay. All right. So here, what do you think? Based on what we see, do I leave it positive or do I make the radical negative? Well, you got a 50-50 shot. So, okay, negative, leave it positive. Sorry. Because let's say I did go ahead and take this graph and I did put the negative out front. What would that negative do? That would reflect in with the x-axis. That would give me the full parabola. So this one here, I don't need to worry about the plus minus. I'm just keeping the plus. Okay, because we restricted him. We wanted a function. Okay. Is everybody okay with that? All right. Now, there's something else I forgot to do. Remember, once you find the inverse, is there something I need to change? Okay. Is the inverse that we got a function? Yes, we guaranteed that because we restricted the domain of the original in the beginning. He wasn't one-to-one, so we made him one-to-one. So if what you get is a function, only then can I put in the inverse notation. Remember, just like yesterday, if it's not a function, you have to leave the y. Okay. Now, let's take a look. The domain and range of this equation, let's see. The domain should be the range of the original function. So I'm going to go ahead and say negative infinity to 2. The range should be the what? Of the original. What? The domain is the range of the original, so the range is the domain of the original. Remember, what are we doing with our x's and y's? We're just switching them. Okay? So all I did was take those and switch them, so I got these. Now, compare that to the graph that I ended up with. Oh, and I accidentally moved the screen there. Move this back to where it was. Okay. The one that I have drawn in red, and I guess I'm actually kind of happy that it drew it in red, is the domain from negative infinity to 2. Yes. Does that graph exist height-wise from 0 to infinity? Yeah, see, it matches up. The original restriction will play a part in what your inverse looks like. Okay. Now, there's only one thing we have left to do, and that's this D right here. Verify that they are inverses algebraically. What that means is we want to show that f of f inverse of x equals what? Equals x. And we want to show that f inverse of f of x equals x as well. That's all we have remaining on this problem right here. So remind me when we come in tomorrow, all we have left is just the composition. We finished everything else we needed. Is anybody having trouble? Anybody confused? Okay. Thank you very much, guys. Appreciate it.